Hello, my name is Gabriel Dolstein, and for my Junior Academy Science Day video, I'm going to be talking about sound. Now, sound is a phenomenon that we all take a little bit for granted because it's just so common and so obvious in our lives that we don't often think twice about it. But a lot of people don't really know what is sound. What makes something sound? Well, sound is actually just a vibration of the air. And many people think it's a wave going up and down, like the bottom one that's green. But in reality, when you see sound, which is hard to see, but what it is compressions and decompressions of the air. And as you can see, here it's very compressed, and here it's very decompressed. And this is what causes something to make a sound. So when you play or strum a guitar, it causes the air around the guitar to vibrate and to become compressed and decompressed because of how the way the strings are moving. These sounds then travel through the air, these compressions, these decompressions, travel through the air and into your ear where your brain processes it as a sound. Now, this brings up an interesting point. What if there is no air? Well, you know, in Star Wars, when they have space battles, you often hear many different sound effects and cool noises, and it's very entertaining. But in reality, when there is no air, there is no sound. So in Star Wars, when you're in space where there is no air, if we were being completely realistic, then there would be no sound at all, because there's no air to compress and decompress. Of course, that's not quite as entertaining, so when you're watching a movie, they often make the sounds. How fast does it usually go? Well, it usually goes about 340 meters per second, depending on where you are on the Earth. But you just generally 340 meters per second, which is really, really fast. And that's why we don't notice it in our daily lives. We don't see any delay between when people move their mouths and between when you hear them talk, because it's so fast you couldn't process the delay. But in some cases you do. For example, lightning versus thunder. When a lightning bolt strikes the ground, it heats up the air around it and makes a sound, the thunder. But it also provides light, and therefore there's light for the lightning. Light is faster than sound, so you see the lightning, the light, faster than you hear the thunder, the sound. And this is why there's often a difference between when you see it and when you hear it. And by figuring out this difference, it's actually possible to calculate how far away the lightning bolt was. But that's for another day. Thank you.